find the limit of this equation.
Calling somebody else fat is close. Calling someone stupid doesn't make you any smarter. And ruining Regina George's life definitely didn't make me any happier. All you can do in life is try to solve the problem in front of you.
The limit is -1.
Oh, crap. I lost.
That answer is incorrect. And we are in a sudden death. If Miss Aaron can answer this problem correctly, we have a winner.
Limits. Why couldn't I remember anything about limits? Limits. That was the week Aaron got his haircut. Oh, God, he looks so cute. Okay, focus, Katie. What was on the board behind Aaron's head? If the limit never approaches anything, the limit does not exist. The limit does not exist.
Our new state champions, the North Shore Mathletes.
Alrighty. So I know you guys have probably seen that clip before. I'm sure you've seen Mean Girls. Anyway, Lindsay Lohan, until this moment, knows something you don't. So we're going to talk about that right now. You've got your paper in front of you. This is coming on. Here we go. Well, at least her character knows something you don't. I'll say that. I don't really know if Lindsay Lohan does my calculus. All right, here we go.
Wait, I've never seen Mean Girls.
Oh, well, you should watch it. It might frustrate and annoy you. It'll probably frustrate and annoy you. All right, we're moving on. Here we go. Yesterday, I kind of showed you briefly kind of how to write limits. And this is the official notation. Here's how you say it out loud. The limit of f of x as x approaches a. Now, the only other time you've seen that arrow has been when we talked about end behavior and we used the word nears. Nears, approaches, kind of the same thing. This one right here says the limit of f of x as x approaches a from the right. That plus sign means that we're coming in from the right-hand side toward a value. And then I left this one off, but the limit of f of x as x approaches a from the left. That one's got a little negative above it. This next little piece is starred for a reason. It says a limit only exists if the left and right side of the number approach the same value. And what we just saw in the clip is that on the board behind the guy she was thinking about, it looked kind of like this, and I'm sure that teacher was asking about the limit of 0. The limit as we approach 0, well, this guy is going up to infinity, this guy's going down to infinity. They're never, ever, ever going to agree, and so the limit does not exist. Here are 3 circumstances where the limit would not exist. The left and right sides approach different numbers. We're going to see something like that here in a minute. F at x increases or decreases without bound. That's this one right here. That's what I was talking about. And the third one is that the function oscillates between 2 fixed values as x approaches c. Oscillates, what's that mean? Bounces back and forth, right? There are some really funky graphs out there. And it might look like this. It seems like a normal sine wave for a while, and then it spazzes out in the middle, and then it normalizes. We're going to see a couple of those today. When it bounces back and forth between the same few values, there's not going to be a limit. It doesn't exist. Okay, so let's look at this first one. Grab your calculator. Somebody borrow mine? Nope, there it is. Finding limits numerically. We're going to type this one into our y equals button. And you're going to want to make sure that you use parentheses in all of the appropriate places or it won't work. And hit zoom 6 to put it in your standard viewing window, your 10 by 10 grid. Looks like a parabola. And when we're looking for a limit numerically, we're going to use numbers to prove that we're coming in as close as we can to that value that it's asking about. This is asking about the limit of the function as x gets close to or approaches -1 from both ends. So take a look at what they've done. They've got numbers that snuggle up super close to that -1. So let's push our trace button. And I'm going to type in -1.1. Hit enter. The y value at -1.1 is 3.31. Now we're going to type in negative 1.01, and we get 3.0301. Then we type in negative 1.001, enter. We have 3.003001. Is anybody not getting their calculator to do that? All right, keep going. Let's type in negative 0.999. And we get 2.997. Negative 0.99 gets us 2.97. And negative 0.9 gets us 2.71. So on the y values, as you're getting closer and closer and closer to negative 1 from both ends, what value does it look like we're skipping over? What are we approaching? 3. So we just say equals 3. Questions on that one? Because this is what you're doing today for a lot of your assignment. You're going to do an actual T-chart and draw it out and do the whole thing. Let's look at the next one. Now, we talked about this a second ago when we graded. What mode should you be in? Radians. Double check your calculator. Make sure that you are in radians. Then go to your y equals button and type in the question. Make sure you have parentheses around 2x. And it takes that function and it says, what's the limit as x approaches 0? We're going to use our trace button and we're going to figure that out. But notice this time we have a blank sort of T-chart. Let's see, we have x's on the top, f at x goes on the bottom. We're looking for the limit as x approaches 0. So I'm going to put 0 in the middle with a question mark. All right, give me a number that's super duper duper close to the right-hand side of 0. I heard it, 0.0001. Then how about 0.001? And 0.01. That'll work. Let's go the other way. What do I put? Love it. Negative 0.0001. Negative 0.001 and negative 0.01. Take your trace button, you type those in, and let's see if we can get the same answers. I think on these two, there were so many 9s that your calculator automatically rounded up to 2. Those probably aren't exactly 2, but I think there were just so many 9s your calculator automatically did that, I would guess. So as you come in from the right and the left, what value are we approaching at 0? 2. So we say equals 2. All right, you fill out the chart and everything on the next one all by yourself. I'm going to hit freeze on this so you can't cheat. need to sneak a peek now, you can. Is anybody not coming up with these values? Is everybody okay? So what is the limit? What is 0.6 repeating? Probably. 2/3. Any questions on that one? You guys need a little bit more time? Okay. Backside. All right, last one for you to try by yourself. Go for it. So what's the limit? It's looking kind of sketchy because we've got, yeah, like we've got positive 1/2, and then we're down at negative 0.8, and then we're at positive 0.3. We have no idea what's going on in the middle because then we go negative 0.3, positive 0.8. It looks like it's oscillating. Your graph was probably pretty funky. Did it look like that? No. It's because your window isn't set to zoom in. Everybody go to window. Because I know you saw that graph look kind of bizarre in the middle. Go to window. Set your min and max at -1 and +1. And let's put those tick marks in increments of 0.1. The y minimum is -1, the y maximum is +1, y scale is 1/10. So this is only a 1-by-1 grid. That is only showing 1 square unit. That looks insane. It's oscillating, which means it does not exist. So this is a Lindsay Lohan moment. And we write DNE. Does not exist. The limit does not exist. Questions? Can I move on? Okay. This next little section, if you understand and you fully grasp this next little piece, then you have fully met the objective for today. It says use the graph to answer the questions. It says what's the limit of the function as x approaches 1? Don't say it out loud, just look at the picture and write down your answer. Check with your neighbors, see if they agree. Most of you either said 2 or 3, I'm guessing. But you're kind of on the fence and you're not wanting to say it out loud because you're afraid you're wrong. Think about the question. The question says, what's the limit of the function as x approaches 1? So as we are approaching 1, what value are we approaching? 2. The second question asks something completely different. It says, what is the value of the function right at 1? Right at 1, it's 3. So it approaches from both ends, it's approaching 2. But at 1, the value is 3. Does everyone see the difference? Those are 2 different questions asking 2 different things. And if you get that, then you're probably going to be okay today. Let's look at the next little section. Use the graph to answer the questions. It says, what's the limit of f of x as x approaches 1? So we're coming in toward 1 from both ends. Uh-oh. What happens? Does not exist. They're approaching 2 different values. So d and e does not exist. What is the function at right at 1? Right at 1, the value is -1. Then it says, what's the limit as x approaches 2? So we're coming in from the right and the left toward the 2. What value is that? 0. And what about as x approaches 0? -4. Notice, and because this is your notes, you might want to even do this. Box it and take note that all of those are y values. When we have written down, one second, Emily. When we have said increasing and decreasing values, I think I said 1,000,000 times to write down x values. And I'm still grading tests where people put all kinds of crazy stuff. So the answer is the y value here. The y value. Emily, question.
Is basically all that what says with x is 0.
No. It says 2 different, this says as x gets close to 0. So as it's getting close to 0, what's y? -4. Which is why on this one, it does not exist, Emily, because even though there is a value right at 1, it's saying what happens as x approaches 1. As x approaches 1, we've got a problem because it's approaching 2 different values. Emily, did you see the difference on these 2? So this one's not saying what is the function at 1. It's saying what is the graph approaching, like what value is it approaching if we go toward 1. At 1, it's a totally different number. Do you see the difference? Okay. Let's move on. Last one. Or not last one, but last one on this page. You guys do this one by yourself. Just round it off. I mean, you don't need to put like -2.9. Just call it -3. It's not a big deal. So when it says, what is the function at 1.5? We go to 1.5 and we're at -3. What's the limit as x approaches 1.5? So we're coming in from the right and the left toward 1.5 and we're still at -3. The limit as x approaches 2. Coming in from the right and the left puts us at 0. And the limit as x approaches 1/2, coming in from the right and the left, puts us at 0. That one's pretty straightforward. There's nothing funky about it. Questions? All right, next page. That straight line, guys, assume that that is dotted. All right, you guys answer those 3 on your own. up as you go and make sure your answers match mine. Christian, you okay?
So if it's not infinity, I've never tried.
And I'm going to explain that here in a second, Christian. I'm glad you asked. Actually, Christian, if you will wait until the next example, you're going to see the difference. All right, right at -2, the function is undefined. There is not a value for x there, so it's undefined. The limit as we approach -2, this guy on the left is headed all the way up to positive infinity. This guy coming from the right is headed all the way down to negative infinity. Those two guys are headed in completely opposite directions. They're never going to agree, so it does not exist. That's that Lindsay Lohan question that was on the board. The limit as we approach -1, as I come in from the right and the left toward -1, it's right there at -1 for the y value. Questions on this? Questions right there? Okay, this last one. This one's on here for a couple of reasons. It says, what's the limit of the function as x approaches 0? And I realize, yes, this could be like a really tall, skinny mountain. Let's assume it's not. Let's assume that that's an asymptote right there at 0. Now, here's the thing. Different textbooks will not agree on how to do this. They're both headed up toward positive infinity. So some textbooks will say the limit is infinity. They're both headed up to infinity. That's it. Some textbooks will say, well, this guy's infinity may not match this guy's infinity, and so it does not exist. Either answer will work on a problem like that. On the AP exam, if they ask you a question that's like this one where it's kind of unclear about which one you're supposed to put, the A, B, C, D answer choices will either have D and E or infinity. It won't have both. Does that make sense to everybody? Textbooks and professors do not agree on this one. Yes, ma'am.
So that's on our homework.
Then either one, I don't care. Either one, I don't care. But the difference is, and this is what Christian was asking, was on that one before. Hey. Yes, thank you, thank you.
And I just, I was just going to give it to him.
Thank you. Okay, cool. No, I'm glad you're on top of that. I was going to take care of that 6 hours. Thank you. Perfect. The one above it has to be does not exist. Do you know the difference? This is because they're headed in completely opposite directions. They're never, ever, ever going to agree. These two, maybe they agree. Some professors say that they do. Christian, do you see the difference?
Yeah.
Okay. Here's your assignment. Oh, wait. What is f at 0? Sorry.
25.
Whoa. 30. There we go. Because it does have a value. All right, here's your assignment, page 54. 2 to 32 even. There's books right over here next to the printer. You may grab one.